In the winter of 1925, inside tomb KV62 in the Valley of the Kings, near the modern city of Luxor, the archaeologist Howard Carter bent over the mummy of a boy who had been dead for more than 3,000 years. He had already lifted a mask of solid gold from this tomb, and a coffin of solid gold beneath it. But as he unwound the brittle linen from the body of Tutankhamun, his fingers found something pressed flat against the king's right thigh. It was a dagger. The handle was gold. The blade was iron. And that one detail should not have been possible, because this was Egypt in the 14th century before Christ, around 1323 BCE, deep in the Bronze Age, deep in the 18th dynasty of Egypt. In this world, iron was so rare and so difficult to work that no Egyptian forge could yet produce it. The Iron Age, the era when people across this region finally learned to master the metal, was still more than 100 years away, and by the most likely reckoning, closer to 150 years. Yet here was a finished iron blade, expertly shaped, resting against the skin of a pharaoh who died before any of it should have existed. It had not rusted. It had barely aged. And when scientists finally read the metal inside it, they found that this iron had never come from the ground at all. Today, we follow what 3 separate teams of researchers discovered when they put this blade under their instruments. We trace where the metal truly came from, how it was worked, and the single question that after almost 100 years, the experts still cannot answer together. Let us begin with the object itself. In Howard Carter's careful catalog, it is listed only as number 256. Today, it rests in the Egyptian Museum in Cairo, and with the ongoing move of major treasures to the new Grand Egyptian Museum, it is among the most significant pieces in that transition. And it is one of the most quietly astonishing things in either building. It measures about 13.5 inches from pommel to point. The hilt is gold, decorated with rock crystal and rows of tiny golden granules so fine they are hard to believe were placed by hand. The sheath is gold as well, worked with a feather pattern and the head of a jackal. And the blade, the part that has puzzled chemists for decades, is iron that has stayed bright and sound for 33 centuries. This is the most studied tomb on Earth, a place we have come back to before, chasing what might still lie sealed behind its painted walls. And yet the strangest object inside it was never the walls. It was this small blade. To see why it is strange, we have to understand where iron sat in the ancient world. Smelting iron, pulling it out of ordinary rock with heat, is genuinely hard. It demands furnaces far hotter than anything needed to melt copper or cast bronze. Across the Near East, that technology does not appear at any real scale until around the year 1200 BC. That is the line the archaeologist Anthony Snodgrass and others have used to mark the true beginning of the Iron Age. That date is not chosen at random. It sits at the edge of one of history's great unravelings, the collapse of the Late Bronze Age, when old empires fell, trade routes broke apart, and out of that wreckage the working of smelted iron slowly spread. Tutankhamun was buried well over a century before it. His craftsmen could pour gold and hammer bronze with breathtaking skill. They simply could not make iron. So where did the iron in this blade come from? The first modern answer arrived in 2016. A team led by Daniela Comelli, a physicist at the Polytechnic University of Milan, working alongside Egyptian colleagues, carried a portable X-ray fluorescence scanner into the museum and aimed it at the blade. X-ray fluorescence reads the chemical fingerprint of a metal without harming it. The fingerprint that came back was unmistakable. The blade was iron, carrying 10.8% nickel, along with just over 0.5% of cobalt. The results were published in the journal Meteoritics and Planetary Science. That figure, 10.8% nickel, is the entire mystery captured in a single number. Iron smelted from rock here on Earth almost never holds more than about 4% nickel. Iron that falls from space, the metal of iron meteorites, runs anywhere from 5 all the way up to 35%. This blade was not forged from any earthly ore. It was forged from a meteorite. The cobalt told the same story. The balance of nickel and cobalt in the blade lined up with the chemistry of iron meteorites almost exactly, the kind of match that does not happen by accident in metal dug out of the ground. And the Egyptians, remarkably, may have understood this. From a few centuries after Tutankhamun, their written language contains a specific term for iron. Translated, it reads as iron of the sky. To a people who watched the heavens with such care, a piece of metal that had visibly fallen from above would not have been mere material. It would have been something close to sacred. Science did not reach this answer in a straight line, though. Back in 1994, an earlier study of the very same blade had measured only about 2.8% nickel, and concluded the iron was probably not meteoritic at all. For years, that reading left the whole question hanging. It took sharper instruments and the 2016 analysis to overturn it and finally settle the matter. Thilo Rehren, an archaeometallurgist with University College London in Qatar, who was not part of the team, said afterward that the new work had placed the meteoritic origin beyond any reasonable doubt. So the iron fell from the sky. On that point, everyone agrees. But knowing that the metal is meteoritic is not the same as knowing which meteorite it came from, or where the blade itself was actually made. And that is exactly where a far harder argument begins. In 2022, a second team went deeper into the metal. Takafumi Matsui, the president of the Chiba Institute of Technology in Japan, led a study that did not just sample a single spot, but mapped the blade's whole surface, reading its chemistry point by point. What they were hunting for was structure, the hidden architecture that forms inside a meteorite across millions of years of slow cooling in deep space. They believed they found it. Running faintly through the blade was a banded pattern, a lattice of nickel-rich lines spaced about 1 millimeter apart. Metallurgists call this a Widman-Staton pattern, and it forms only in a certain class of iron meteorite known as an octahedrite, and only when the metal cools over almost unimaginable spans of time. You cannot reproduce it in a forge. One of the study's authors, Tomoko Arai, later described the moment the team recognized that pattern as the high point of the entire project. The blade held other clues as well. Scattered through the iron were tiny dark flecks, the remains of troilite, an iron sulfide mineral that is common in meteorites and almost unheard of in earthly iron. Those flecks had lost much of their sulfur, and that loss only happens when the metal is heated to around 1300 degrees Fahrenheit. Yet the delicate banded pattern was still intact, and that pattern is wiped away if the metal grows too hot. Put those two facts side by side, and you can read the temperature of an ancient forge across 3,000 years. Whoever made this blade worked it with real care, somewhere below 1700 degrees Fahrenheit, hot enough to shape the metal, never hot enough to erase its signature from the stars. And that restraint is its own small marvel. The simplest way to shape iron is to heat it until it glows soft and yielding. These smiths did not have that luxury. Push meteoritic iron too hot, and it grows brittle and cracks apart. So whoever made this blade had to coax it into form at a lower heat, with a patience and a touch that Egypt, by every other measure, had not yet developed for this metal. The team even went searching for the parent meteorite. Out of every catalogued meteorite on record, the closest chemical match they could find was a fragment called Karga, recovered near a plateau in Egypt's own western desert, with a nickel content strikingly close to the blade. But the closest match is not the same as a proven source, and the researchers were careful to say so. The exact rock that fell from the sky is still unknown. And then the same team turned their attention to the gold hilt and found something that pointed away from Egypt entirely. We will get to what the gold revealed in just a moment. If you find these documented but genuinely unsettled mysteries as fascinating as we do, take a moment to subscribe, because this is the kind of story we follow here. The discoveries that careful science has confirmed, and that careful science is still arguing about. Now that gold hilt, the gold of the handle, the team reported, held a trace of calcium, but no sulfur. To them, that suggested the gold had been fixed in place with lime plaster, an adhesive that the Egyptians did not normally use. Egyptian workshops favored gypsum plaster instead. Lime plaster does not become common in Egypt until many centuries later. So Matsui and his colleagues drew a bold conclusion. Perhaps this dagger had not been made in Egypt at all. Perhaps it came from somewhere to the north, from a kingdom called Mitanni. There is a tantalizing piece of evidence that seems to fit. Among the most famous documents to survive from this exact period are the Amarna letters, a cache of diplomatic messages written on clay tablets and exchanged between the great powers of the age. These were letters between kings, the superpowers of the late Bronze Age, trading gold and horses and royal brides to hold a fragile peace together. Most of these tablets were not even found in Mitanni or Babylon. They were dug out of the sand at Amarna, the abandoned capital built by Tutankhamun's own father, the pharaoh Akhenaten, which is how we can still read, 33 centuries later, exactly what one king promised another. In one of them, the king of Mitanni, a ruler named Tushratta, lists the gifts he sent to the Egyptian pharaoh Amenhotep III, who happened to be Tutankhamun's grandfather, to seal a royal marriage, and among those gifts is an iron dagger with a gold sheath. The implication is almost too neat. The blade that Carter found against the boy king's thigh may have been a family heirloom, a foreign wedding present handed down across 3 generations, from Amenhotep III through Akhenaten to Tutankhamun himself, until it followed him into the dark.